So we have two types of special right triangles, the first of which is a 45, 45, 90. Well, a 45, 45, 90 means that this angle is 45, and this angle is 45, and this angle is 90. And thinking back to what we learned in Unit 3 about angles, if two angles are equal, then the sides opposite them are equal. This particular triangle is an isosceles right triangle. And as part of this isosceles right triangle, we have some really cool ways that we can figure out our missing side lengths. So our standard sides in a right triangle, it says in a 45, 45, 90 triangle, the ratio of one leg to the other is 1 to 1. So whatever my legs are, one of them is one length, the other one is always the same. These two legs are always congruent. The ratio of the hypotenuse to either leg is about 1.4 to 1. So I have this triangle here, this right triangle, that with side lengths of 1 and 1. And if the two legs are 1 and 1, my hypotenuse is going to be 2. Here's our rule. In a 45, 45, 90 triangle, I have a magic number. My magic number is square root of 2. If I'm going from a leg to the hypotenuse, if I'm going up to a big side, I'm going to multiply by the square root of 2. If I'm going from the hypotenuse down to the leg, I'm going to divide by the square root of 2. And that will always be true. So in this 45, 45, 90 triangle, it tells me the base is S, so then the other leg must be S. My magic number is square root of 2. So to get from this side here to my hypotenuse, I'm going up, so I'm going to multiply by the square root of 2. So I end up with S times the square root of 2. So we're going to go ahead and look at some examples. So these are problems 7, 8, and 9 from your warm-up, and we're finding, or from the checkup, and we're finding the missing sides. So for 7, I'm given this side is the square root of 50. This is just 5. And then I need to find S. Well, I know if this leg is 5, this leg must also be 5. That's just the way it works. Number 9, I need to find my missing side of S. So my magic number is square root of 2. To get from the hypotenuse down to this side, I need to divide because I'm going to something smaller. So I have 8 times the square root of 2 divided by the square root of 2. Well, whenever I have the exact same thing on top and bottom, they're going to cancel each other out, and I am just left with 8. So my leg is 8, which means my other leg is 8. Number 9 says, what is the length of S? Well, this is a 45, 45, 90 triangle. It may help for you to draw it this direction. This would be S. This would be 14. Whatever this side is on the left is the same as my base. My magic number is square root of 2. So to go from 14 down to the square root of, to the other side, I'm going to divide by the square root of 2. And 14 divided by the square root of 2 is 9.9. So that means that my base is 9.9. It also means that my other side is 9.9. So that would be my answer for this question. So remember, for 45, 45, 90, your magic number is square root of 2. If you're going up to a bigger number, you multiply. If you're going down to a smaller side, you divide. Special right triangles can be useful in the real world, especially if you need a right triangle with congruent legs of 45, 45, 90. Our second type of special right triangle is a 30, 60, 90. It's important to note that in a 30, 60, 90 triangle, the hypotenuse is always twice as long as the shortest leg. The hypotenuse is always twice as long as the shortest leg. So the question says, what does the Pythagorean theorem tell you about this triangle? Well, if I'd used my Pythagorean theorem, I know that across from the right angle is always C. The other sides are A and B. What it would say is that 1 squared plus S squared is equal to 2 squared. if I were to do some math and actually solve that out, what I would learn is that in this case, B, or my missing side S, is really the square root of 3. And this is where you get your magic numbers for this triangle. So my magic numbers for 30, 60, 90 are 2 and square root of 3. 2 always goes on the corner with a 60. Square root of 3 always goes on the corner with a 90. The same rules apply. If I'm going up to a bigger side, I multiply. If I'm going down to a smaller side, I divide. So for this particular triangle, if this side is S, then my hypotenuse is going to be 2 times S, because I had to go up, so I needed to multiply. And my other side, well, I have to multiply, so that's going to be S times the square root of 3. So looking at some examples, says, number 1, what is the length of S? We're actually going to find both sides. So it's a 30, 60, 90. My magic numbers are 2 and square root of 3. So to get the hypotenuse, I'm going up, so I'm going to something bigger. So 12 times 2 is 24. To get S, I'm going to a bigger side, so I'm going to multiply. 12 times the square root of 3, I can just leave that as 12 square root of 3. For number 3, it may help you to turn the problem sideways, which is what I'm going to do. It asks us for the 2 missing sides. So my magic numbers are 2 and square root of 3. Remember, 2 goes on the corner with 60. Well, I don't have a 60, but I know this is 30, and this is 90, which means by default this is 60. So 2 goes here, square root of 3 goes here. I have my 10. I cannot go this direction because there's no magic number there. So stop. It can't happen. So I have to go the other direction. So I have to go down. To get to this side, I'm going down, I divide. 10 divided by 2 is 5. To get S, I have to go up to a bigger side, so I'm going to do 5 times the square root of 3, which I'm just going to leave as 5 square root of 3. Question 5 asks me, what is the length of A, the altitude of the equilateral triangle shown below? Well, I have a right triangle here. My magic numbers are 2 and square root of 3, because it's 30, 60, 90. So I know what this side is. I need to get this side, so I'm going to be multiplying. So I'm going to multiply 5 square root of 3 times the square root of 3. Well, you can put that in your calculator, or you can do a little bit of algebra. Whenever you have 2 square roots like this that you're multiplying together, you can combine it into 1. So instead of the square root of 3 times square root of 3, it's the square root of 3 times 3. Well, 3 times 3 is really 9. And the square root of 9 is actually 3. So I really just end up with 5 times 3, which is 15. So this missing side, side A, is 15. Alright, there's a little bit more information you need to write down somewhere on your notes. And the first of these things is we're writing down some ratios. So the first ratio we're writing down is the ratio of legs of a 30, 60, 90. This does not mean 30 minus 60 minus 90, by the way. That means it's a 30, 60, 90 triangle. So when we think about a 30, 60, 90 triangle, my generic sides I work with are 1, 2, and square root of 3. So the ratio of one leg to the other could be 1 to the square root of 3. It could also be square root of 3 to 1. It could be 2 to 2 square root of 3. It could be 3 to 3 square root of 3. It could be 4 to 4 square root of 3. All of these are possible ratios. All of these are possible ratios. That doesn't mean we have to have them, but they are possible. Now, if we were to talk about the ratio of the long leg to the hypotenuse, well, again, thinking about my 30, 60, 90, this is 1 square root of 3 and 2. My long leg in this case is square root of 3. My hypotenuse is 2. So my ratio could be square root of 3 to 2. It could also be 3 to 2 square root of 3. It could also be 3 square root of 3 to 6. It could also be 2 square root of 3 to 4. And there's lots of other options it could be, but those are going to be the only ones we're really going to talk about. And I promise I'm telling you this because it's going to be on your quiz.